SwayamPrabha. Digital India. Educated India.
Welcome to today's lecture. We have been discussing about the 4-stage architecture of mineral exploration, and we just started with the reconnaissance stage, which is the first stage in which our materials are these geological maps, small scale geological maps, reports that are written by workers who have worked in the area before, and in the present day context we do also have satellite imageries, or there are many such kind of much regional scale features like magnetic anomaly, gravity anomaly, which have been acquired from aircrafts, which are basically the airborne anomaly maps. So, these give us the preliminary idea or the first hand information that helps us to choose or to focus on certain selected areas. So, this particular stage, reconnaissance stage, is followed by a detailed mapping stage, in which all the lithological units with broad structural pattern are represented. As I just mentioned, if we go from a small scale map, which is a 1:50,000 scale, to a 1:20,000 or even a little larger than that, it would be possible for us to represent the geology in a with representation of all the geological elements present in any particular smaller area, and that gives us further information. And those kind of maps, which also we have the scope of representing the local scale structural features, which sometimes are very important in terms of the localization of ore bodies. As you have seen before, the structures, different types of structures that are present in the rocks, and the different generations of structures, they play important role in localization of ore bodies. Say for example, when we are discussing about the Noamundi basin, the Horseshoe Synclinorium, even though the basin is essentially an ancient banded iron formation basin, but the localization of ore in terms of the high grade iron ore is very much controlled by the structure, with the later folding and the formation of the favorable locales, where the enrichment of the primary iron formation could take place to give rise to high grade ores. So, such kind of structural patterns has to be very well studied, represented, and there is the basic idea, and the detailed maps are produced. The third stage is essentially for target delineation, means by this time we have already reduced the areas or chosen the areas on which the exploration work is focused. Smaller from reconnaissance to target delineation, we have been able to successfully eliminate areas in which we could conclude that the possibilities of or probability of occurrence of any ore body could be minimum or near 0, which we may be wrong in many of the cases, but that is how it goes. And so, it is a process of elimination. So, when we come to the target delineation stage, there we intensify our efforts to identify or to be certain about the existence of an ore body. So, that is our ore body is the target. Here we can use the methods, different types of this geophysical methods, the geochemical methods, and of course, the geology will always be. By that time, we have already used all our geological knowledge in identifying the area where we would like to delineate the target. Essentially, because of the fact that the geological work will always be based on whatever is available on the surface, the ore body or the associated rocks and the many other associated features as they are exposed on the surface can be studied in all greater details, but the subsurface will always remain an uncertainty for us. So, we need to delineate to understand or to work out the disposition of the ore body in the subsurface, to ascertain its size, the parameter which would essentially which you want to know, and the most important aspect will be to understand the geometry of the ore body. The geometry of the ore body, which will be extremely important for us to understand, and geochemical exercise is also carried out on the surface, but the interpretations of the geochemical methods would be far reaching and would just not be based on what we see them on the surface, because they are the manifestation or the reflection of the presence of an ore body below. So, by the completion of the stage, a favorable result which is obtained through these methods that are carried out, where we can this stage we can call as the prospecting, the geophysical or the geochemical prospecting methods would result in either negation or towards establishment towards establishing the existence of an ore body. So, the last stage is essentially the exploratory drilling the estimation. So, here we do study the area on the largest possible scale map, which is a mine scale geological map, which is this mine scale geological map which is almost like 1:2000 or even larger, where all the minutest features associated with the ore, the ore body, and all the minutest the features in terms of alteration characteristics, the different other type of lithologies, their contacts, and all these possible minutest details are all represented on a mine scale geological map. And here, once we are through the previous stage, where we are definite about the existence and we have delineated the target, there we will go for directly physically intersecting the ore body, and that is done through the drilling, so like by putting intersecting the ore body directly by making drill holes using drilling machines, and that possibly gives us the most direct, because even a target delineation, a success in a target delineation stage might come out to be a failure during the time when we are actually trying to, because this most of the method of the geophysical method is quite indirect and based on the methodology that we are using for interpretation, and even though right at this point of time the methodologies are quite elaborate and involved, and they give very definitive results, but the actual success, the end of the success story in an exploration program like a 4-stage architecture that we are putting it in hierarchically, only the intersecting the ore body by a drill hole is gives us the most direct evidence of its presence. And then through this we are able to recover the samples of the ore body. We can analyze the ore body and can estimate the weight, the content of the metal of our interest. So, for example, the copper in an ore body, what is the percentage that we have there. So, the assaying, to first find out the quality criteria and to see whether that meet our standards or our expectation, and the 3-dimensional modeling of the ore body, because it is very essential to know how the ore body is disposed in 3 dimension, because that gives us a that are the primary knowledge that is required to plan for the exploitation process for the mining. And these exercises are very involved, and they involve a lot of modern methodologies. They have they give a lot of scope of computerization, and these involve a lot of mathematical methods, which a little bit of it we could possibly some idea we can obtain here. So, this exploratory drilling, by this time this exploratory drilling methods are over, the ore bodies existence, its extension, down depth extension, lateral extension, in a broad sense will be established, which will lead to a further evaluation as a project, considering all the microeconomic factors, which we will also be discussing when we go to the project evaluation parameters. So, this 4 stage exploration architecture actually it ends there, where the exploration company possibly will hand over the data to the agency who would be interested in mining the or to exploitation of the particular mineral resource, and then would subject that particular resource to all sorts of quality, quantity assessment, feasibility analysis in terms of and then the detailed estimation of the ore body in terms of the reserve. So, what we have seen that we would reach a stage where we should be able to report in terms of how much of the reserve is actually measured or proved or with very little uncertainty, and then any amount any quantity of the reserve that we report would be still more than that with a little greater uncertainty, as we have seen in our measured, indicated and inferred category, or proved, probable and possible. And then this has to be subjected to a lot of other economic analysis for finally whether a project to be feasible to exploit or to. So, this actually is the 4 stage architecture. Okay. So, this is a diagram which gives us an idea about the stages of the exploration project. Not only that, it also gives us the full picture up to the stage that a mining a mineral based project, its very beginning and almost when it ends with the decommissioning or rehabilitation, although we will be mostly be concerned with only the part which starts as a conceptual planning, then a detailed planning. Conceptual planning could exactly what we saw we put under the category of reconnaissance by looking at the available material that are with us, then the detailed planning stage. So, here we could see this thick line here represented is the cost that is involved in different parts of the project. So, we could see that the reconnaissance stage or the even in many of the situations in the present time, the reconnaissance stage could be very much like a pre-exploration analysis from existing data, and once the data are acquired, they can be used and reused n number of times, still trying to extract more and more information. And so, this part of the work actually involves the least of expenditure, and as we go from conceptual to detailed mapping to target fixation, and then when we come to the exploratory drilling. So, this is this part where the cost actually goes up, and so that gives us an idea that that many of the situations that a particular agency or a government, before going to this stage, which involves the maximum of the expenditure in terms of the project. So, the decision making process has to be very judicious here, and many of the projects get abandoned almost at this stage because of the uncertainty in delineation of the target or any other parameter not being satisfied. So, many projects get abandoned at this stage, but the project which goes up to this, and this after that the mine starts producing. So, this mine activity, so here the cost involved becomes less because the mine starts to get revenue, sell the ore or the metal that is being recovered, and then towards the last stage when the mine is closed, then it has to be decommissioning and rehabilitation and so many things. So, we are only concerned about it, and this gives us an idea as to how the expenditure goes up when we go from a reconnaissance stage to a stage where we actually establish the presence of an ore body and go to the stage where it is ready to be exploited in a mine. Before we go to the detailed discussion on mineral exploration, its methodologies and the intricacies, let us have these things. These are the things which you can keep in mind, that most mineral deposits exposed on the surface are actually discovered. We can, I mean, this is a statement pretty philosophical, because at this and the beginning, the first quarter of the 21st century, when we have more than 2 centuries of history of exploitation of mineral resources by us, exploration, and as I have also stated before, that the area of land which can be told as never been explored or by or never been seen or having no idea are actually very less or shrinking day by day. On at this stage of time, it would be difficult to say how much of that area is still there. So, those deposits which are exposed on the surface could be easily discovered by the early explorers. So, the situation is that, and also most large giant deposits are discovered, because larger is the deposit, easier it is to discover it. We sometimes use the word as giant deposit, means the deposit which has a very huge quantity of the metal. For example, some of the gold deposits in the Abitibi province like McIntyre Hollinger mine, and even we can also think of a mine like Kolar in India, which could be labeled as a giant deposit compared to the ones which are much smaller. In fact, the number of giant deposits are definitely small, and most of the productions come from the much larger number of smaller deposits. And so, philosophically, it would tell us that chances of discovering such giant deposits are decreasing, going smaller and smaller day by day, and the deposits which actually are exposed to the surface are also or the chances of getting deposits which are exposed in the surface are also going down day by day. Here there is a very nice, very interesting relationship, and people who generally work on quantification of this mineral exploration, the ideas how to quantify or how to model the mineral exploration process by using many sophisticated mathematical and statistical tools, which would be definitely be interesting to learn them in a higher level. But say for example, we can think of a parameter which is called a discoverability index or discoverability of a deposit. Here the parameters are Q is the grade, so Q is the grade, T is the tonnage, and H is the depth from surface, let us say depth of occurrence. So, that means if H is 0, the deposit is occurring on the surface. So, this relationship tells us that the discoverability, even we can even think of in terms of a diagram here. So, if we put say quantity in say tons, millions of tons or whatever, and discoverability I here. So, if the quantity is high, so it is basically the discoverability is also high. So, it is kind of sorry, I mean the lower. So, in term at the right at this present time, the discoverability of much smaller deposit is rather larger, and this might even have a curve like this. So, if we think of the, say we put also another parameter as the depth to from surface. So, if it is replaced by h here, I versus h, similarly discoverability will also go down like this. So, greater is the greater is the depth at which deposit is likely to occur, the more difficult it will be for it to be discovered, and the chances of discovering such huge giant deposits are also low day by day, and also the chances of getting the very high grade deposits are also low. We can justify them because better or the higher is the grade of a deposit means the higher is the concentration of the particular metal, and so its manifestation will be more conspicuous, more prominent, rather than a deposit which is very low in its grade. Means we can always think of a deposit of a very high grade which is lying at a lower smaller depth compared to a deposit which is of equivalent grade, but lying at a greater depth. So, the one which is lying at a smaller depth is always likely to be discovered much easier or faster than the one which is lying below. Similarly, we can also discuss in terms of size. If a deposit of a high tonnage is on the surface, is far more discoverable than a identical deposit of that size which is lying at a greater depth. So, the present efforts are mostly focused on exploration below the cover. So, in most of the cases the deposits are concealed in different geographical areas. We do have almost like 20 to 100 meters of thick soil cover, or sometimes if the soil has evolved for a good amount of geological time, it is converted to what we call as regolith, which is the paleo soil, and it is quite challenging to discover or to explore for such deposits which are below the cover. And so before we get into the mineral exploration topics or the seeing the case histories or the procedures and methodologies in detail, we should keep it in mind that exploration today is actually multidisciplinary in its nature. Not a single deposit that has been discovered in the recent past or even in the distant past is not out of any single method like a geological or a geophysical or a geochemical. So, mineral exploration today is multidisciplinary. Even in case of geophysical, sometimes we need to use more than one technique and to synthesize the information jointly before getting any meaningful interpretation in terms of presence or absence of an ore body. And today's mineral exploration is both knowledge and data driven, because the knowledge means what we have acquired so far from our study of the mineral deposits of this wide spectrum that we have seen, and also the data that we have generated. Sometimes the data need not necessarily be related to any theory or hypothesis related to ore geology or genesis or the science of ore deposit formation. The data could be, for example, the digital image data that is acquired, which essentially we know as the satellite imageries. So, those data are huge, or many such kind of data. There are some data being acquired to be used, so that has given rise to a lot of sophistication in the kind of technology to deal with such data, and mineral exploration at the present day today is quite an elaborate, involved, sophisticated exercise involving all sorts of modern methodologies of soft computing. Essentially mineral exploration has become much more computerized, although we in this particular lecture series we will not be able to touch them much, but can see certain important aspects. So, that is what exactly what I have said, that it has come of age with the advent of remote sensing, and then spatial data modeling technologies such as geographic information system, and these are the ones which should be in our agenda, that we should be learning them in future if we want to understand or to contribute to mineral exploration effectively and actively. Let us first okay. So, with this much of a background information about mineral exploration and what it is today, the first and foremost methodology of conventionally or a traditional thought of mineral exploration is the geological methods. So, essentially geological methods means the knowledge that we have acquired about the geological processes that are responsible in formation of mineral deposits could be translated into elements which would be helpful for us to do mineral exploration. These terminologies like guides. So, here there are certain different types of elements that could be thought of, that a physiographic guide, structural guide, stratigraphic guide or lithologic guide. So, they will all be coming out from the basic understanding that we have developed. Say for example, we say about physiographic guide, we have seen placer the process of mechanical concentration giving rise to placer deposits. And these placer deposits are essentially young deposits, even though there are placer deposits that formed as early as in the Archean, which is exemplified by the classic Wheatwater-Strand paleoplacer gold uranium deposits. So, essentially if we understand that placer deposits can form, and they form in the fluvial cycle, and considering the fact that they represent and sometimes the kind of point bar type of deposits which form in meandering rivers. So, then it leads us to the immediate idea that paleo channels or paleo river channels are the ones which should be the obvious targets or the areas which actually would be looking for if we are looking for placer deposits. And we know placer deposits are essentially of minerals like tin, tungsten, gold, uranium, and even titanium, thorium, which are essentially beach placers, and this tin, tungsten, gold, these are the alluvial type of placers which they form. So, if we are looking for alluvial placers, that we have to look for paleo channels, and paleo channels will make some very well identifiable geomorphic features or the physiographic features, which could be immediately could be thought of something which what we mean by a physiographic guide. And the drainage pattern in a particular area is a very we will be seeing this drainage pattern a little while in discussing some case study for that. So, the drainage pattern which could be identified on a map, on a topo sheet, and also from a very small scale maps like a satellite imagery, which gives us synoptic view of the earth surface. We can see the drainage pattern. The drainage pattern is of many different types. They have been classified based on the and this drainage pattern is very much controlled. The drainage pattern is very much controlled by the structure in the rock structure in the area, and by looking at not only structure but sometimes the lithology also, which becomes very the feature which can immediately be identified and based on that the areas to explore could be chosen. And structural guides, this is a very important aspect, because we have what we essentially call as the structural controls. Structural controls of localization of mineral deposits. So, these structures could be the much regional scale structures or could be local scale structures, and we in many of the cases we find that an area which has been affected by multiple phases of deformation, and each stage of deformation has acted till the time of the formation of the ore body, and sometimes we can clearly identify any particular phase of deformation which has been actually responsible in localizing the ore body. So, it is very essential to work out the structural features. So, generally the structures would be like important structures like faults, which will make prominent feature on any surface manifestation on any part part of the continent, where they could be identified by a proper geological map, or situations which are coming out from where we can see a synoptic view of the surface of the earth by very small scale maps like satellite imagery or anomaly maps. And also the lineaments, which are the large scale features, and so on, and we will continue our discussion on this geological method with different types of guides in the next class. Thank you.